Okay, today we are going to talk about light. The first part of light will be on reflection. Okay, so you have learned about visible light as part of the EM spectrums, and you have learned some properties about wave. So I'd like you to pause the video to think about these two questions. Okay, now I'll go through the answers to these two questions. Which of the following statement is false? Okay, we know that all waves can undergo reflection and refraction. So the first statement is correct. Okay, the answer is B. Okay, the speed of light in air is not 3 times 10 to the power 8 kilometers per second. It is actually 3 times 10 to the power 8 meters per second. Okay, this value of 3 times 10 to the power 8, okay, you need to memorize it. It's the speed of light in vacuum and in air. Okay, we say that it's the fastest possible speed for any objects, okay, in the universe. Okay, and we know that light can be dispersed, they can spread out, and light can travel through a vacuum. Okay, if light cannot travel through a vacuum, then the light energy from the sun will be unable to reach the earth, and the earth will always be dark. Okay, and the second question, when light travels from one medium to another, which means like it changes from solid to liquid or liquid to gas, its speed changes. The answer is, it is true. Okay, it is true. Okay, because when the speed changes, it causes the bending of light, which is refraction. You should have learned in lower sec before that when light enters from air to glass, it will bend towards the normal. Okay, that is because of the change in the speed of light in different media. Okay, let's move on. Okay, so today we'll cover basically 14.1. And how does light enables us to see? And that is mainly because of reflection of light into our eyes. Okay, so you should be able to know the terms used in reflection. You should be able to know the image properties of mirror image, how to draw ray diagrams to show light being reflected off a surface into our eyes. Okay, and obviously the law of reflection. Okay, so you have this. You have seen before the rain vortex at Jewel Changi Airport. So what happens for this is they actually shine light and the water surface becomes a screen, okay, where the light is reflected off the water surface into our eyes. Okay, and because of this reflection and the water acting as a screen, you are able to see many patterns on the water surface. Okay, so we also have this comics. Okay, so this guy over here, okay, the yellow speech bubble, he's saying that I think my eyesight is getting worse. I cannot see the words clearly. And this girl went on to say, oh, that's because your screen is too dark. Try making it brighter. And then this guy over here starts thinking, I wonder how do we see an object that does not give out light? In this case, the laptop is a luminous object. We say that luminous objects are objects that emits light. Okay, so this guy is able to see words on his laptop because the laptop is luminous. It gives off light, and the light directly enters the eyes. So he's able to see the things on his laptop screen. But what happens if your laptop screen is too dark? There is insufficient light, and when there's insufficient light entering our eyes, we are unable to see the thing, the object. Okay, so that's why the girl was saying, try to make it brighter and you will be able to see the words. Okay, so you should have learned this before in lower sec. Okay, over here we have a luminous object, which is the lamp. Okay, so how do we see the lamp? Very easy. For luminous object, which gives off light, the light from the luminous object directly goes into the eyes over here. Okay, so we can directly see a luminous object just by the light ray going into the eyes. Okay, but how can we see non-luminous object like a picture on the wall over here? Okay, so this picture is a non-luminous object. It doesn't give off light. So I can only see this picture if I have a light source. Okay, there must be a light source present. So the light source, the light from the light source will hit onto this picture. It will get bounced back, which we call it reflected back into the eyes. Okay, then I will be able to see this object. What happens if I switch off this light? When I switch off this light, there is no light source. I couldn't see this picture because no light from this picture will be entering my eyes. Okay, so we say that for non-luminous object, it can only be seen when they reflect light from a luminous object. In this case, it's the light bulb, into our eyes. Okay, just remember, in order to see things, light must always enter our eyes. Okay, but there are certain cases whereby I say that there must always be light entering our eyes, but there must be sufficient light. Just like in the case of the first scenario, whereby the computer screen is too dark, there is insufficient light going into our eyes, we are unable to see it clearly. The same goes for any other objects. So you have this black object called Vantablack, as shown in here. Okay, so they spread Vantablack onto this aluminium foil. Okay, so one look, you see that, wow, it's black and it's flat. It looks like it's just like nothing, or it's a hole, or it's a very flat black surface. But actually, there's a lot of creases, okay, on this aluminum foil. Okay, that looks like this. There's a lot of creases here, but you can't see the creases because this Vantablack will absorb more than 99% of the light falling onto it. So there's light from a light source, okay, from in the room. You switch on the light, there's light. The light falls onto this Vantablack, but 99% of the light is being absorbed by this Vantablack. Only 1% gets reflected into your eyes. So the amount of light that goes into your eyes is very little, so you are unable to actually see clearly what is in this black patch. Okay, too little light is reflected from the black coating to our eyes. Okay, and then we move on. Okay, we use ray models of light to represent light because we can't really see exactly how does the light behave. So we usually use a model to represent light to ensure that we can study how does light behave. Okay, so in ray model of light, you should have learned before, is always represented by straight lines. Okay, with an arrow to indicate the direction. So in this case, the light source, then the light ray. Okay, we call it a ray. Okay, so it's just a straight line with arrows. So whenever you are doing your exam questions or theory questions, please make sure you draw with a ruler because light only travels in a straight line. Okay, and make sure you have your arrows to indicate the direction of the light movement. Okay, then you have a bundle of light rays. It will be called a beam. So you have a parallel beam, converging beam, diverging beam. Okay, but we'll talk about converging and diverging later on in lengths. Okay, then we move on into the law of reflection. Okay, you should have learned that whenever light hits a surface, it gets bounced off. This bouncing of light is called reflection, and there is certain law. Okay, so before I move on to the law, we learn about some of the terms that we use first. Okay, so the first one, you have the mirror surface. Okay, and then you have a light shining onto the mirror surface. Okay, this light ray that shines onto the mirror surface is called the incident ray. Okay, you need to spell correctly, incident ray. Okay, and then the point at which it hits the surface, I draw a normal to it. Okay, this is your normal, which is 90 degrees to the surface. It's always perpendicular to the surface. Okay, then the light will bounce off it, and the bounce of light is called the reflected ray. Okay, reflected ray. So incident ray, reflected ray. Okay, and then next, very important, you need to know the angles. Every time for light, the angles is always measured with respect from the normal. It's not with respect from the mirror. It's always between the ray and the normal. So if the normal is not given in the question, it is very important for you to draw where is the normal. Okay, so in this case, the normal is drawn for you. So it's between the ray and the normal. If it's between the incident ray and the normal, it's called the angle of incidence. Okay, again, spelling must be correct. And then another one, the angle between the reflected ray and the normal, okay, which is R over here. Okay, it's called the angle of reflection. Just take note, it must be small I, small r. Okay, okay, test yourself. Can you pause the video over here and then do it yourself now? Okay, let's come back to go through the answer. Okay, I hope you are able to get the answer as follows. First one, angle of incidence. okay, you should be able to know this is the incident ray. Okay, the ray that strikes the surface is called the incident ray, and the angle is always between the ray and the normal, which is B. Okay, then the angle of reflection, this will be the reflected ray. Okay, the ray that is bounced off the surface, reflected ray, and between the ray and the normal, which is C. Okay, so the normal will be the dotted line, and then incident ray, reflected ray, as follows, green and blue. Okay, then we go into the law of reflection already. The law of reflections, the first law states that the incident ray, reflected ray, and the normal all lies in the same plane. So what do I mean by that? Okay, I have a picture that is 3D. It simply means that if on the same plane, it actually means on the same surface. Same surface. Okay, so if I were to put a piece of paper or a piece of wood or any surface, okay, that is upright, is 90 degrees to this mirror, you will see that the incident ray, the normal, and the reflected will all fall nicely on this flat piece of surface. Okay, they will all fall nicely on this flat piece of surface. I will not have incident ray that strikes on this plane and then reflected ray that bounce out towards you. They will all happen on the same surface. That's what I mean by all lies on the same plane. Okay, and then the second law, which is the more important one, that's why I highlighted it. Okay, you need to know this angle I will always be equals to the angle R. Okay, no matter which angle I shine the light at, the angle of incidence will always be equal to the angle of reflection. So if it's 50, it will be 50, it will be 20, it will be 20. Okay, so I equals to R. Important, you must know. And remember, it's small I, small r, not big I, not big R. Okay, so we look at a few examples. You have a mirror that, a light ray that strikes the mirror AB at an angle of 30. What's the angle of reflection? Okay, so I'm interested in angles. The first step I need to know is, I need to know where is the normal. Okay, so if you've done correctly, you should have drawn the normal, which is 90 degrees to the mirror surface, represented by this dotted line. And then my angle is always between the ray and the normal. So this is the incident ray. The red ray is the incident ray. So this angle of incidence is 60. Angle of reflection will also be equal to angle of incidence, which is 60 degrees. Okay, next one. You have another example that shows like this. They ask for angle of reflection at CD. So I'm interested at this surface. Okay, CD, not at AB. So you need to do step by step. AB and CD are both mirrors. So there will be 2 times reflection. The first reflection, you should be able to get, okay, I will reflect at 60 because this angle will be 60. So I will undergo reflection. Okay, I will be equals to R, 60, 60. And then you're going to use your mathematics. This will be 30 degrees. Okay, and use your mathematics. Okay, use your mathematics. Okay, this will be 70 degrees, 30 degrees, 80 degrees, 110, 180 minus 10, 70 degrees. And then you draw your normal again. Okay, so it will be 20 degrees because 70 plus 20 is 90. So the angle of incidence is 20 here. Angle of reflection here will also be 20. Okay, let's move on to the next section. After the law of reflection and different terms, we are going to learn about there is 2 different types of reflection. Okay, the first type of reflection, it happens on a very smooth surface. And when you have a parallel beam of light that shines onto it, the reflected ray remains parallel to each other, okay, which can be seen from this first picture over here. I have parallel light shining onto a smooth surface, okay, because all the normal will exactly be, let me draw the normal. Oops. All the normal will directly be upwards. Okay, because all the normal will be straight up, all the rays will be reflected parallel to each other. Okay, this is what we call a regular reflection. Regular reflection. Okay, but then when we have reflection on a rough surface, not everything is smooth. When it happens on a rough surface, we say that it gives rise to a diffuse reflection, or in other words, irregular reflection. Okay, this is because when you have a parallel beam of light that shines onto it, they get reflected in many different directions. The reflected rays are not parallel to each other now. Okay, why is it not parallel to each other? Because the surface is rough. Okay, the normal will not all be straight. Okay, let me draw for you the normal. In this case, the normal is here. In this case, the normal is here. And in this case, the normal is here. Okay, you will see that my normal is not straight. Okay, my normal is in many different directions because the surface is not flat. Okay, so the law of reflection still applies in each case. In each of the ray, angle I will still be equals to angle R, just that the normal will not be straight up as in this case. Okay, so we can say that in both regular and diffuse, law of reflection still applies. In regular one, all the rays have the same angle of incidence and reflection. In diffuse, similarly, all the rays will have the same angle of incidence and reflection, just that the normal on the uneven surface are not parallel to each other. So they are different as compared to the previous rays because of the difference in the normal. Okay, so summary of 14.1a. We learned that the law of reflection says that incident ray, reflected ray, and normal at the point of incidence all lies on the same plane. Okay, that means they all lies on the same surface. Second law, which simply states that the angle of incidence is equals to the angle of reflection, I equals to R. And then we also learned that there's two types of reflection. The first one is regular reflection. All the rays are reflected in the same direction because the surface is very smooth. And for such regular reflection, you will be able to see a clear image of yourself, which is like a mirror, still water. You can see a clear image because all the rays bounce back in the same direction. But for irregular reflection, it occurs on rough surface like your table, your paper, or water that has been disturbed, like a waterfall. Areas near a waterfall, the water is being disturbed. Okay, where you don't have a smooth surface, you will not see an image. Okay, because the surface is rough, the light rays that hit the surface are all reflected in different direction. Okay.